We will learn about the spiral model. The spiral model is an influential software development methodology that has revolutionized the way we approach complex software engineering projects by embracing an iterative and risk-driven approach. This model empowers teams to deliver high-quality software that meets evolving business needs. In this presentation, we will explore the key principles, advantages, and practical applications on the spiral model, equipping you with the knowledge to elevate your software engineering practices. Introduction to the spiral model. It is the first conceptual. The spiral model was introduced in the 1980s by Barry Boehm, a renowned software engineer. It emerged as an alternative to the traditional waterfall model, addressing the limitations of the linear sequential development approaches. Second, risk driven approach. At the core of the spiral model is a focus on identifying and mitigating risk throughout the development life cycle. Each iteration of the spiral revolves around risk assessment and planning to ensure project success. Iterative refinement. The spiral model embraces an iterative development process where each cycle brings the project closer to its final form. This allows for continuous feedback testing and improvement, ensuring the software aligns with evolving requirements. Key principles of this spiral model. First, risk management. The spiral model prioritizes the identification, assessment, and mitigation of risks at every stage of the development process. This proactive approach helps teams navigate complex projects with confidence. Iterative development, stakeholders collaboration, close collaboration with stakeholders, including clients, end users, and cross-functional teams, is crucial for the spiral model. This ensures the software aligns with evolving business needs and user expectations. Flexibility and adaptability. The spiral model is designed to be flexible and adaptable, enabling teams to respond to changes in requirements, technology, or market conditions throughout the development lifecycle. Advantages of the spiral model. Enhanced risk management. The spiral model's strong emphasis on risk identification and mitigation helps teams anticipate and address potential issues before they escalate, reducing project failures and cost overruns. Improve quality. The iterative nature of the spiral model allows for continuous testing, feedback, and refinement, ensuring the final software product meets high quality standards and user expectations. Adaptability to change. The spiral model's flexibility enables teams to quickly adapt to changing requirements, technologies, or market conditions, making it well suited for complex long-term software projects. Phases of the spiral model. Planning. In the planning phase, the project objectives, constraints, and alternatives are defined, laying the foundation for the development process. Second, risk analysis. The risk analysis phase involves identifying, accessing, and prioritizing the potential risks that could impact the project, allowing the team to develop strategies for mitigation. Engineering. Third is engineering. The engineering phase focuses on the actual development of the software, incorporating feedback and iteration to ensure the final product meets requirements. Fourth is evaluation. The evaluation phase involves testing the software, gathering the user feedback, and assessing the project's progress against the initial objectives, paving the way for future iterations. Risk assessment and mitigation. Risk identification. The spiral model emphasizes the proactive identification of potential risks such as technical, organizational, or market related challenges that could impact the project success. Risk analysis. Each identified risk is carefully analyzed to determine its likelihood of occurrence and potential impact, enabling the team to prioritize and develop appropriate mitigation strategies. Risk mitigation. The spiral model encourages the implementation of the risk mitigation plans, which may involve prototyping, contingency planning, or adjusting the development approach to minimize the impact of identified risks. Fourth is continuous monitoring. Ongoing risk monitoring and re-evaluation are essential in the spiral model as the project environment and requirements can change over time, necessitating, necessitating the adaptation of the risk management strategies. Stakeholder involvement and collaboration. Open communication. The spiral model emphasizes open and transparent communication between the development team and all stakeholders, ensuring alignment and buy-in throughout the project lifecycle. Collaboration, collaborative decision making. Stakeholders are actively involved in the decision making process, contributing their expertise and perspectives to shape the project's direction and ensure the final product meets their needs. Continuous feedback. Regular feedback loops are established, allowing stakeholders to provide input, review prototypes, and suggest improvements at each iteration of the spiral model. Alignment with business objectives. By fostering close collaboration with stakeholders, the spiral model ensures the software development aligns with the organization's strategic goals and evolving business requirements. Iterative development and continuous improvement. First is plan. The planning phase sets the foundation for each iteration, define the project's objectives, constraints, and potential solutions. Second, analysis. Analyze. Risks are carefully analyzed and mitigation strategies are developed to address potential challenges that may arise during the iteration. Third, develop. The engineering phase focuses on the development and implementation of the software, incorporating feedback and making necessary adjustments. Fourth, evaluate. The evaluation phase involves testing, gathering user feedback, and assessing the progress of the iteration against the initial objectives. The spiral model's iterative nature allows for continuous improvement where each cycle builds upon the learning and feedback from the previous one. This approach enables teams to adapt to changed requirements, incorporate user feedback, and deliver software that exceeds stakeholders' expectations. Adapting spiral model to different contexts. Agile integration. The spiral model can be seamlessly integrated with agile methodologies, allowing teams to leverage the strengths of both approaches, such as iterative development, customer collaboration, and rapid response to change. Enterprise level projects. While the spiral model is well suited for complex long term software projects, it can also be adapted to address the unique challenges of enterprise level initiatives including cross functional coordination, legacy system integration, and regulatory compliance. Bespoke software solutions. The spiral model's flexibility makes it an excellent choice for developing custom software solutions tailored to specific business needs as it allows for continuous refinement and adaptation based on client feedback and evolving requirements. Case studies. Successful spiral model implementations. NASA's space shuttle software. NASA successfully applied the spiral model in the development of the Space Shuttle's complex software systems, enabling the agency to manage risks, incorporate stakeholders' feedback, and deliver reliable and high-performing software solutions. Banking software system. A major finance institution adopted the spiral model to develop a comprehensive banking software system, allowing the organization to adapt to evolving regulatory requirements, user needs, and technological advancements throughout the project's lifecycle. Healthcare information system. A leading healthcare provider used the spiral model to build a cutting-edge information system, leveraging the model's iterative approach to ensure the final product seamlessly integrated with existing systems and met the stringent requirements of the medical industry.